Hello, everybody. It is Miss Ray, and welcome back to school. We are going to go over graphing in biology. So it's really important. It's a life skill to know how to interpret graphs and know how to create graphs. Okay. So um, we are going to go over some different types of graphs. We're going to go over how do we want you to make graphs in biology class, because we want them to be good graphs. Okay. And then we are going to practice them at the end. So feel free throughout this video to pause as needed or rewind as needed, so that you are able to understand the content and get everything written down. And if you have any questions, please let me know. So first things first, we're going to go over some different types of graphs. So on your notes, I would, if I were you, maybe draw a little sketch of each of these types of graphs. So the first one's a pie graph. I'm sure you've all seen this before. So we are looking at relationships between parts and the whole. So the whole here is favorite sports. Okay, the whole pie graph represents favorite sports. And then we have different categories. Okay, different parts, different types of sports. Okay. Next we have, sorry. Next we have a bar graph. Okay, so this is comparing different categories of data, or maybe we're showing changes of data over time. So in this graph, we are looking at favorite color. Okay, so on the x-axis, and if you don't remember the x-axis, it's the horizontal, and the y-axis is the vertical. So x-axis, we have the different colors voted on. And then on the y-axis, we have the children. So I'm guessing this was maybe in like a kindergarten class or something like that. And the children voted on their favorite colors. So 8 kids said that their favorite color was red. Okay, so usually we see categories on the x-axis and then like numbers or percents on the y. The next one is line graphs. You've probably seen these before in math class or wherever. So again, we're using x and y axis. Usually the points are connected, which creates a line. So this is usually showing how something changes. So we can see, even if we don't look at the numbers, we see that something is going up and then it's dropping. Okay, so easy visual for us to see that. Now, we want to make sure we have our data. So this is looking at temperatures on the 22nd of February. So we know at 8, it was 24 degrees. At 10, it was 32. At 12, it was 36. And at 1400, it was 29. Okay, so again, showing how values change over time. And again, we have like numbers on our y-axis. We have time on our x-axis. Okay, now there are a few things wrong with this graph. Okay, I want you to look at it. I want you to see if you can figure out what is wrong with this graph. Now, with this graph, we have temperature, we have degrees. Now, we don't know if it's Fahrenheit or Celsius. Okay, so the person making this graph should have put a little parentheses and put Celsius or Fahrenheit, and that is the unit. Okay. All right, scatter plots. We are showing a bunch of data, and then we have a line in the middle that represents the line of best fit. Okay, and this is showing the relationship. You won't see this one as much in biology. All right, components of a graph. So we need a title, and that includes an x-axis title and a y-axis title. Okay. Now, with this graph here, the y-axis has a title. It is the number of children. The x-axis does not have a title. So I want you to think about what would the x-axis title be? And it would just be like colors. Okay, colors voted on, whatever. Okay. And then make sure, again, we include units. So again, oops, I'm not sure what's happening here. Sorry about that. Okay, so again, we need units. Okay. All right, what is this graph missing? Well, it is missing a title. Okay, we don't have a title telling us what is the graph showing us. Next one, what is this graph missing? It is missing axis titles. Okay, so y-axis and x-axis. I want you to think about what would the axis titles be if you were making this graph. What would you make the titles be? I would maybe do something like percentage voted on, and then, or percent favorite, something like that. And then app. Okay. All right, constructing a graph. So, first thing we want to do, constructing a graph, we want to look at our variables. So normally you will have a data table like this, or you will collect data. So again, data table like this, you will collect the data, okay? So for our dependent variable, okay, typically this is on the y-axis, okay? Now, if you don't know what a dependent variable is, it is something that is a result of the independent variable, okay? So our independent variable is what you as the scientist control, okay? So if I'm looking at this experiment here, how temperature of water affects breathing rate, okay? So what are we controlling as the scientist? Well, we are controlling the temperature. So we are playing around with different temperatures of water and we're seeing, okay, what happens to the breathing rate, okay? So typically we see that independent variable on the left side of the data table. Okay, so right here we see that is true. Okay, now what happens as a result of the independent variable? Well, that is the dependent variable. Okay, so typically it's on the right hand side of the data table. Okay, and again, at 15 degrees Celsius, when I put a raccoon in a 15 degrees Celsius pool of water, what happens to their breathing rate? Well, it's at 25 breaths per minute. Okay, so it's what happens as a result of the independent variable. So remember that for the future. Okay. Next thing, determine the scale. So we don't want our graph to be too squished or too spread out. So how I like to do this is I like to look at my data and I say, okay, what is my highest number? So if I'm looking at my independent variable, okay, that's going along the x-axis. My highest number is 27. So I'm going to build my graph out all the way to 27. Now you'll notice we don't start at 0, right? You don't have to start at 0 in a graph. We don't have any data before 15. So you could just start right at 15, just like it does in this graph, okay? So we go from 15 to 27. Now, it's okay if you go above this 27 a little bit. Like if you wanted to make it even and go to 30, that would be okay. But you don't want to go all the way to like 100 or something like that, okay? That's overkill. That's too much work. We want to save time, okay? And then we look at the breathing rate that is going along the y-axis, okay? Now, again, look at your highest number. Now, you can't just look at this bottom number because that's not your highest, okay? Our highest is here. It's 60. So you can see that on the y-axis, it goes all the way up to 70, which is fine. Again, it's okay if you want to go like 5 or 10 above the highest number, just to show that on the data tape or on the graph, okay? Now, when you think about what type of graph is this? It is a line graph, okay? All right, so again, the other thing is don't let it be squished. So if I give you a lot of room to make your graph, take up the whole thing or most of it, okay? The other big thing is making your scale consistent. So we see here like on the y-axis, it goes by hundreds, 100, 200, 300. I don't want to go 100, 150, 375, 410. Like that's weird, right? That doesn't make it easy to read. We want it to be nice and even and consistent, okay? Now, it's okay if you go by 2s, 4s, 5s, 10s, 20s, okay? But don't go by something weird by like 7s, okay? That's weird. Don't go by like 3s, okay? Do something that's like intuitive, okay? And it's also okay if you skip lines, okay? So like on graph paper, like this is a 1-to-1 ratio here, but like if I did 100, 200, 300, like that is okay as well, as long as it is consistent. What is wrong with this graph? All right, first of all, it's really squished, right? What could this person have done to make their graph prettier? They could have skipped lines here, so instead of gone 1, 2, 3, 4, okay? Give themselves some room, okay? And they also don't have a title here. Next thing is constructing a graph from the data. So you need to plot your data points. if you have multiple sets of data, so in this example, we have push-ups and sit-ups that are being graphed. So they have a key here so we can tell apart the data. If these lines were both just black, we would not be able to tell apart the data, right? We need two different colors. Or if you were doing a bar graph, you could have the bar and then like maybe one of them is dotted, a bar, one of them is striped, okay? So those are two different ways you could make a key. And then we want to have a title. So the title does not need to just be like, it can be one word. You saw in this example over here, how temperature of water affects the breathing rate. Okay, so make sure we just have a title that tells us exactly what we need to know. Okay, so maybe I want you to try right now, I want you to try and think of a better title for this graph. So maybe I would have said instead, how many push-ups I do over the course of a week. Okay, how many push-ups I do every day? How many push-ups Tommy does every day? Okay, so we want the graph. We want to be able to look at the title of a graph and know what we're looking at here. All right, we're going to do two practice problems, and I'm just going to read through these. And now at the very end of the video, I'm going to go through and show you the answers. Okay, so I want you to try to do them on your own first, though. So number one, clams were placed into various temperatures of water. Use the information in the data table below in order to create a proper scientific graph to answer the corresponding questions. So we have our data here. We have what is the dependent variable, and this is a little cut off, sorry for that, but also it says down here, what is the independent variable? So we're looking at the dependent variable is what happens as a result of the independent variable. So in this scenario, what is the scientist controlling? Well, they're controlling the various temperatures of water. And then we can also remember that normally the independent variable is on the left side of the data table. Okay, so the independent variable is going to be the water temperature. I, as a scientist, am controlling that. Now, if we look at dependent variable, what is happening as a result of the independent variable? Well, the number of developing clams. So I want you to go through. I want you to try and graph this on your own. And the other thing is you need to decide what is the best type of graph. Okay, I'll give you a hint. It is not a pie graph. It is not a scatter plot. Okay, not a pie graph, not a scatter plot. So pause here, make your graph, and then come back. All right, our next practice question. Natalie sets out to run 15 kilometers. Every 30 minutes, she checked her pedometer to determine how far she had run. Use the data below to create a proper scientific graph and to answer the corresponding questions. So we need to determine what is the dependent variable, what is the independent variable. Okay, so what is Natalie controlling? So she is controlling how long is she running. Okay, she's controlling how often she is checking her pedometer. So the independent variable is the time. Okay, how long is she running? What is happening as a result of the time? Well, she's running. So how long is she running? Okay, what is the distance? So dependent is the distance, independent is the time. So again, go create your graph and then come back to see both answers to both practice problems.